In this video, we're going to do lesson 1.2 and 1.4. Okay, so lesson 1.2, this is probably a review for most of you. We're going to talk about order of operations. You may have seen the acronym PEMDAS before. I wrote it out a little bit differently. I wrote it horizontally instead of vertically to remind you that you're supposed to work left to right across the expression. And then I put the multiplication, division, and addition and subtraction together because remember, as I'm going from left to right, I'm looking for multiplication or division. Whichever one comes first, left to right, that's what I'm going to do first. Okay, so let's go through this. Remember, P stands for parentheses. So here's our example expression. And if I look across there, there's no parentheses. So that step is done. Next thing I'm going to look for is exponents. So I have some exponents right here. So I'm going to go ahead and do that operation. 2 to the second power. 2 squared is 4. And the rest of the equation I'm just going to copy down exactly the same as it appears above. So I replace the 2 squared with a 4. My exponents are all taken care of. Now, working left to right, again, I'm looking for multiplication or division. So that's subtraction, no. Here I have division. Alright, so this would be the next step that I'm going to do. So I have 16 minus, because again, I'm copying the rest of the equation down. 8 divided by 4 is 2, and then plus 14. Alright, so multiplication and division are done. Now I'm looking for any addition or subtraction. That's all I have left. So I'm going to go left to right. 16 minus 2 is 14. 14 plus 14 is 28. Okay, now we're going to look at using order of operations to evaluate this expression. And this one has variables. So I have x squared, I have y, I have z. And they give me what each of these things are equal to. And the directions say substitute and then evaluate. Evaluate is what we did in the last problem. Now we have to substitute first. Hopefully you guys are familiar with the concept of substitution. They're saying x equals 4. So anywhere in this expression that I see an x, I'm going to replace it with a 4. And I like to use the sports analogy. You have substitutions in all sports, but in soccer is the only one I know of where they put up this little sign and they say number 10 is coming out and number 17 is going in. So 17 replaces 10 in the game. And in our expression, 4 is going to replace x. So where there is an x, I'm going to replace it with a 4. And I'm going to put it in parentheses. It's just a good habit to get into because we have multiplication here. When I have 3 times x, I don't have to put a symbol in there. But if I wrote 3 next to a 4, it might look like 34 squared. So just get in the habit of putting everything in parentheses when you substitute. Okay, so I substituted 4 for x. Now I can substitute 5 for y. So wherever I see a y, so I'm going to copy the rest of this. Wherever I see a y, I'm going to replace it with a 5. Alright, the y comes out of the game, the 5 goes in. Alright, and then z is equal to 3. So I'm going to have, instead of z, I'm going to have 3 to the third power, and then I need my closing parentheses. Alright, now we're going to follow the rules just like we did in the last example. Alright, so the first thing I'm looking for is parentheses, and I need things inside parentheses. Alright, so I'm going to copy this. Now inside this parentheses, I need to simplify first. Okay, again, follow your rules. So inside the parentheses, first thing I'm going to look for is exponent. So I have 3 to the third power. Alright, that's 3 times 3 times 3, which gives me 27. So I have 2 times 5 plus 27. It's all still in parentheses. Okay, I'm still working inside this parentheses. The next thing I'm going to look for is multiplication or division. Well, I have 2 times 5 right here, so copy everything else. 2 times 5 is 10, so I have 10 plus 27. Alright, and now I can simplify my parentheses down to just one number. So I have 3 times 4 squared plus 10 plus 27, which is 37. So the parentheses can go away now because I simplified everything in them. Okay, so I followed my rules inside the parentheses first. Now that I've gotten rid of the parentheses, I'm still back to, next thing is exponents. So 4 squared would be 16. So I have 3 times 16 plus 37. Exponents are done. Next, multiplication or division. I've got multiplication right here. All right, 3 times 16 is 48. So I have 48 plus 37. Addition or subtraction, that's all I have left. 48 plus 37 is going to be 85, and that would be my final answer. Alright, you got two more examples here. I want you to pause, try them on their own, and then come back and I'll have the answers up for you to check your work. Okay, so here's the answers to those two. Look and see if you didn't get these as your final answers. Maybe you look through my work and see where the difference is between mine and yours. If you can't figure it out or don't know what you did wrong, put a star by it and then ask me about it in class. Okay, now we're going to talk about the distributive property. So to do that, we're going to look at a problem. John burns 420 calories per hour while skating. How many calories did he burn skating this weekend? And here's the amount of time that he spent skating. There's two different ways we can do this problem. First, we can say John went skating for 2 plus 3 plus 1 hours. So that's 6 hours, and 420 times 6 is 2,520. So he burned that many calories. Or we could do it this way. On Friday, he burned 420 times 2 calories because he went for 2 hours. And then Saturday, he burned 420 times 3. Plus on Sunday, he burned 420 times 1. Alright, so 420 times 2 would be 840. 420 times 3 is 1260, and 420 times 1 is 420, and if we add all those up, we get 2,520. So two different ways of solving the same problem. Now, what I wrote out over here is actually using the distributive property, because here's the hours, 2 times 3 times 1. So if I wrote this way, all right, 420 times the hours he spent. I put them all in parentheses, and because they're all numbers, we can add them all up. We know it's equal to 6, so we multiply 420 times 6. What I did here, all right, is actually using the distributive property. I multiplied 420 times 2, 420 times 3, and 420 times 1. That's what I did over here. Okay, doing this is called the distributive property. We're taking what's outside the parentheses and multiplying it by every single thing that's inside the parentheses. Now, some of you might be thinking, well, this way is a lot easier. Why wouldn't I just do it this way every time? I just add them all up. Now I only have to multiply once. Well, that works for this problem because all of the things that are inside the parentheses are numbers, so we can add them all up. But what happens if we have some variables in there, some x's and things that we can't add together because we don't know what they're equal to? Then we have to use the distributive property. So how it works is we're just going to take what's outside and we're going to multiply it by everything that is inside, okay? Not just the first thing, but every single thing. So I'm going to multiply 7 times 3w, and I'm going to multiply 7 by -5. Okay, so 7 times 3w, well, 7 times 3 is 21, so that would be 21w. And then I have 7 times -5. Whatever this sign is, I'm just going to take it with me when I multiply by the second thing. So 7 times -5 would be -35. Alright, and then that would be it. That would be my final answer. There's nothing else that I can do there. Alright, this example, now the 4 is at the end, but the concept is still exactly the same. If that makes you really uncomfortable, you can rewrite it and put it at the beginning. That's totally fine. These two things are exactly the same, so I'm going to multiply 4 by every single thing that is in the parentheses. So this time I have to do it 3 times. Alright, so 4 times 6v squared would be 24v squared. Alright, 4 times v would be positive 4v, and then 4 times -3 would be -12. Done. Alright, you try the last example. Last thing that we need to talk about is a new vocabulary word, like terms. Okay, so we're going to fill in this little chart so that we know all about like terms. Alright, I don't know if you questioned me at all or wondered why. But if we look at like these examples, I said 21w minus 35. I said we were done. That was it. You might be asking, well, why don't we subtract those? Why don't we do 21 minus 35? These would be what we called unlike terms, okay? We can only add and subtract things that are exactly alike, all right? And so to be a like term, all right, they have to have both the same variable or variables, okay, and the same exponents. So to be like terms, all right, I have to have something that has the same variable and the same exponent. All right, so what would be some examples of that? Let's look at some. Let's say if I had 2x plus 4x. Those would be like terms because they have the same variable, they both have x, and they have the same exponents, okay? There's no exponent in front of, or with the x's at all. So these are like terms, all right? What can we do with like terms? We can either add or subtract them by combining the coefficients. Another math vocabulary word there for you, so if you don't know that word, you might want to write down this definition. The coefficients are the numbers that the variables are being multiplied by, so those numbers in front of the variable. All right, so 2x plus 4x, we said they're like terms, so that means I can combine them. I can add them together. 2 plus 4 would be 6, and then I just keep the variable exactly the same. All right. Other example of some like terms. Let's say 3y squared minus 7y squared. Those would be like terms. Again, same variable, same exponents. Okay. We could also have a term with multiple variables. So if I had 5xy plus 11xy. All right. Same variables with an S, they have to have both of them. So this one has an X and a Y, that one has an X and a Y, so they can be combined. They are like terms. Some non-examples, some things that are not like terms. 2x plus 4y. We can't combine those because this term has an X, this term has a Y. Can't go together. If I had 3x squared plus 6x. Not like terms. They both have x's, but this one is x squared and this one is just regular x. So they can't be combined. Alright. Then if we had something like 3xy minus 4xyz, okay, again, these would not be like terms because they don't have the exact same variables. This one has a z and that one does not. So we're going to do a little practice simplifying things and looking for like terms. So if I look at this expression, I have 1, 2, 3, 4 terms, okay? And then I'm looking for ones that have the same variable and the same exponent. The only ones I see are these two right in the middle. So I'm going to combine those two and leave everything else the same. So 4y to the third stays the same. 2 minus 8 would be negative 6. Y, and then plus 5 at the end. So that's all I'm doing is finding things that are the same and then combining them. So why don't you try B and C, do your little summary activity at the end, and then we'll see you in class and check on these answers.